Welcome back, guys. This will be day, is it 15 or 16? Okay, I think 15. This will be day 15 of me trying to learn TypeScript. Now we're just doing these conditional types for fun. As the guy said, you use this like when you're creating libraries and stuff. You need this when you're really like just writing an application. We already have anything we need for just writing an application, but we still need to want to finish the course. We just want to finish the course. Okay, we just want to do everything in the course and have knowledge. Okay, so today we did mapped type yesterday, so we ended at map type. So today we're going to do map types with conditionals. So let's just get started. So if map types, I stepped onto the road to type Tom Foley. What? I stepped down the road to type Tom Foley. Then to type Tom Foley conditional map types. One more leap. Okay, I'm not saying they are not cool. Okay, or that they are not useful. They are in certain scenarios, but you can create some really hard to read code if you're not careful. So use them wisely. Let's take our optional soldier example from before. So if we have this, if we create this, we're just creating the same type but with every key optional, and then for the value we're just taking in the value from that soldier type. Okay, so what if instead of making all the properties optional, we wanted to filter any non-string properties? We'll do that with conditional map types. Okay, I see what they're going with this. So we'll do key in the type of soldiers, and then if this extends string, we just return that, and then for everything else that is not extending a string, we return never. Okay, so I mean, like, it can't be used, obviously. That means age, and age in this case will be in type never. But doesn't that make the entire type never? So I remember when I first learned about the never keyword, like, when you're on tagged, I think it's tagged. No. There's something. No. It's like when we were trying to combine unions, and then say we have like name, and that side on top it's a string, and this type on the underneath it's like a number. Then the resulting type will be never, right? And then if the resulting type is never, then the entire type becomes never. Like, that's what they said. I don't remember, like it was somewhere where we did types, I don't know, somewhere in type narrowing maybe, but let's just not go back. Let's just read. The conditional soldier extends a string only and evaluates to true only to evaluate. Okay, the conditional soldier key extends string only evaluates to true, and thus the property is included as soldier if the property is assignable to string, otherwise it evaluates to never, and the property is excluded. Okay, one really cool thing to note is that because we use soldier key in the conditional, the more specific type of the branch property is preserved, resulting in a type of, then this won't be used. So in this case, it doesn't make the entire type never. It just would be removed, I guess. So assignment, they just look at the tip again. Okay, the compliance team at Support AI is reviewing what user visible data can be edited and what should be locked. Okay, so complete the editable fields generic type. It should return a new type. It should return a new type with the same keys as T. Replace all functions or objects fields with never. Keep primitive string as is. So it's a lot. So the extends function objects can be used to check if the type is a function or an object. So like if we do this and it's true. Why is it noisy? What's happening? It's happening in resident. Okay, so return a new type of the same type T. Replace all functions with so like we just do return a new type with the same keys as T. Okay, so we're just doing something like this. Okay, so it will be mapped types with let's see, I already created. Okay, it's in conditional types, and then we're doing mapped types. We're doing, let's just rename. We're doing mapped conditional types. Why is it getting noisy? What's happening? So we do key in keys of t, right? Okay, okay, let's use the syntax, because like sometimes the syntax becomes an issue. Just do this. Like I've noticed that like when it's like this, it's like it's easy to like see for you guys. Okay, and then we can just increase the thingy, and then we can just have this here. Okay, so in key of t, right? And then want to filter out first. Let's just filter out the function and object. So return a new type with the same type t, replace all functions with never. Okay, so what should be extending? Okay, key of types. Okay, see, return a new type with the same keys as t. Okay, so it will be the same keys, replace all functions and object with never. If, let's just say, so we'll do t, so we'll do t key extends, right? Extends function. Okay, let's see what happens. What's happening now? Who's trying to create a function? Function or object. Function or object. How to say function? Or we use capital letter. Okay, thank you. Function or an object. Then replace all function with never. If this is true, we'll replace this with never. Else, yeah, we just use the t dot key. I think this is what we're supposed to do. It's no space. We need to be able to see the entire code. Okay. Yeah, the code is just long, bro. Like, so this shouldn't be there. Okay, so like I think this is what we're supposed to do. I mean, there's no way for me to verify. This is boring. We just go back and forth, guys. There's no way. Okay, so like there's no way for me to verify. So what we're going to do is that we're gonna okay, yeah. So it's keeping the same keys, but checks the okay, let's just see, return a new type with the same keys as t, replace all functions of the fields. Okay, yeah. Okay, I'll just see the test. Maybe we'll get an idea from the tests. Test compiled. I think this is what we're supposed to do. I'm not sure though. These conditional things are like, that's why they're not used. They're confusing you. Okay, let's just ask GPT if you're on the right track or not. I don't want you guys to see my history. Thank you, Aunt. I was searching how to fight a Komodo dragon the other day. I'm kidding. So let me just copy this and see what ChatGPT says. Because like I suck at programming. Your current implementation is almost correct. The function callable types, but object will also include arrays and function. So, but that's what they gave us there. So we'll do this extends function. Okay, we'll do it like bit by bit, I guess. The notable example, then the type will just be the data will be never. an object, and callback will be never. And then this one, like, okay, so we'll check ChatGPT saying we have to check if it extends a function first, and then never, and then if TK extends a function, like it's the same thing. If TK extends like an object, what's happening? Then never. Okay, so let's see. What ChatGPT was saying, like it's saying, okay, like if it extends, like this code currently saying, if it extends function or an object, do never. But it's the same thing, stupidity. If it extends function, never. If it extends an object, never. So like, come on, ChatGPT is just trying to make. Okay, and then we just return TK. Yeah, TK. Yeah, we're using K. Yeah. Okay. Come on. I solved it. Come on, ChatGPT is just trying to take credits from my bag. Just trying to decredit me, man. It's saying it's almost correct when it's correct. Okay, extracting keys from types. Okay, let's just check the time. It should be 10. Okay, 11. Map types don't just let you build new object types, but they are also used to extract keys. Say with this object, they are also used to extract keys. Okay, they can be used to extract. Okay, they can also be used to extracting. They don't just let you build new objects. They can also be used to extract keys. Say that we have this extracting keys from types. Okay, we have this. Yeah, but we've already extracted keys from type. Where I think it was. Yeah, like we said, like, okay, no, we were saying that it should use the keys from that object. We didn't extract them. We're just saying it should use. Okay, now imagine you want to get just keys of the fields that are string based, because for a filter, a drop down, or feeding to an LLM must summarize records. First, we create an object where each key either returns the key name or never. Okay, so key of T. Then if the value extends a string, just return that key on or never. Okay, so what's happening? And imagine you want to get you want to get just keys of the fields that are string based, maybe for a filter, a drop down, or feeding to an LLM that summarizes records. First, we create an object where each key is where each key either returns the key name or never. Yeah, this will just return the key name, but here we're already saying key in key of T. So this gives you something like this. Yeah, it just gives you the same thing. If it's like a name, to be just the value will be named. So okay, now maybe if you want to do something like this, yeah, this would work as this. This is what was confusing me. Why would you use the but like I remember but it was the union. It was enums that time where they I don't with the name and then age. If like it was satisfying, it would have been aged. And then branch. Okay, now we index into the type using all its keys. Okay, now we index into that type using all of its keys. So like type, we create a string key union, it's a generic type. Then string keys. Where's the string keys? String keys, and then passing key of T. Okay, we'll pass in key of T, the keys, and then if K is a key in T, whatever. Okay, we've made the object into a union of its values. So keys, string union, soldier. Is that soldier there? So it will be a union of what? Of name and branch. This is useless. What? Yeah, because this where is it? String keys is returning something like this. Okay, it's returning a type that looks like like this. So string keys, and then we're passing we're just creating a type string key union. So this will return like a type like this type. So here we just pass in some type, and then what will be returned is a type with string key union. Like, where does it make it a union though? Key of T. This will pass in the keys here, and then the keys are returned into a type like this. Okay, so here when we like pass in, we should get like an object with just a name and branch, right? Okay, so like I guess it up. Where does it become a union? Like what? I'm confused. Somebody is building a signal waiting tool. They want to automatically pull numeric fields from a given type and let engineers assign weights to them. Create and export a number key type that iterates over keys of T. Filter only keys whose values are number, evaluates to a union. Just so we do the same thing, but I want to know. Okay, let me just ask GPT. When does it become a union of keys? I imagine it would just be a type like let's say like name whatever, a type like, so just paste that, and then exactly what you have described is a trick for turning certain keys of a type into a union of key. Let's break down why it works using your soldier example. So if we have this conditional mapping, yes, this will just return like some types that will just remove this, because and then so we have an object type where certain fields map to their own key name and others never. Yes, they map to their own key name. Okay, so step 2, extract the values. Okay, so key of T for soldier is name, age, and branch. Okay. So like, okay, it's here in string case way. Oh, let's see. Nope. It's here where things turn into string keys. Let's just look at string keys. String keys returns a type that maps to itself, right? So when we assign type T, AT would be soldier, right? Yeah, it would be keys of soldier. So yeah, we're still passing in the keys of soldier. So it will return a type that maps to itself. String union keys, and then passing the object. Yeah, like it's happening here. The magic is happening here at string keys. We're passing in the keys that be name, age, and branch, and then it checks whether they extend a string and return a type that maps to itself. So let me just agree that it works. It works like that, but it's hella confusing, yo. Okay, it works. Okay, it works. So local development, I think I'll just be done with the course now. This I'll do it on my own. I know how to npm install global TypeScript and then check the version of the TypeScript. This, like, there's no need to do a video about this. And then the test config files where you configure your TypeScript Yes, next, this is the yes, you're targeting compiler options, libs library to include in compilation is what APIs are available. Target specified like ECMAScript target, yeah, for the JavaScript output. You can put ES6, yeah, or put the years like years 2025. I see, like, yeah, there's 2025. The standard 2025 just came. I saw a video, so you can put years 2025 if like that's what you're. So ES is great for us because we're starting a new project and we want to use the latest. I recommend mapping. Oh, so next just map to the most recent. I recommend paging this to a specific version before you ship. You ship your project. Okay, so assignment npm this. Why do you get a package.json? Oh, no, init npm init y. Yeah, you get a package.json. So add a ts config file to the root of your directory. I think for ts file you do npm. I guess we need to try. So this is the one I use, the terminal. Oh, this is so far, man. Yeah, this is like what I used to use, guys. This is the font I used to use. My eyes can see bigger. I think to get the ts config file, you do so for npm init you get the packet.json. Let's just so npm init y. Here you get the packet.json. Oh, we already have the tsc, the json for. Let's just, we wanted this so that we just compile whatever. So for tsc, I think you do tsm init y, unknown option. Okay, tsc init one error, control path init in the extension. I don't know, like something tsc, but for the npm init we get the packet.json. There we can, this is like when you're trying to create like a JavaScript project or TypeScript project, whatever. Just delete it and then go back. Create an index.txt with the following code. Yeah, so now we're gonna be starting a project, whatever. Okay, this one is a bit weird, but just roll with it. Okay, so we create a project with the function main returns a void, and then a function will come and then call that function. Run the tsc to make it compile. You should see and you compile. So you copy paste this and then you get a you submit, and then yeah, obviously to submit this you have to be a member. More tsc config.json, there's like telling us what this if it's true, it makes type checking more strict, and then the other ones I don't know, but like it's something I can read by myself. So there's declaration files. Yeah, I've seen something like this. If you've ever seen funky looking .d.ts files, and not what they are, the declaration files. They don't contain type information. No runtime code is allowed. They're very useful for defining types for JavaScript. Okay, so they don't contain type definition, so I'll just read it on my own whenever I get the time. I'm not using JS libraries, so you declare module, see, we're even talking about assignment. I guess it's like worth reading because something TypeScript language server. It's for auto completion type checking at on your editor. TypeScript language server. We've used TSA from the command line to compile TypeScript code, but that's often not how it's used in practice. Please note that my TypeScript family uses as a language server to provide type checking features in your IDE. Yeah, it provides this. Researching the TS server in VS Code in Z in your view. Okay. TypeScript ignore, TS ignore. This will ignore like type checking. See, it's really hard to avoid using this, but sometimes they're the best choice among the. Let's say TS ignores the next line's error. Yeah, like it suppresses error. Yeah, that's like in TypeScript too. I think it compresses warnings. No type check, disable type checking. This is the things you don't want to use, because you want type checking. That's the only reason you're using JavaScript. So install Vite. I know Vite for creating your React apps. Vite or Vite, whatever. Creating. What is Vite? Vite is a newish build tool that focuses on speed and stability. It does a few key things that make it great for many projects. And then even fast, Golang powered ES build. Simple to use. Server-Vite is built and compiler that compiles your code in development on the fly, so you don't need to manually rebuild each time you make a change. It's amazing. So I guess it's done. I'll just have to read it. Okay, I have a test. I have a quiz, a stats quiz tomorrow. I have to go get into that now. So yeah, that is that. I think the TS config file, we edited it manually and just edit the code. We wrote it manually, but there's a TSC whatever file. If I just want it alone, just run TSC. I think you just run TSC. I think can we delete it and then just run TSC and try to. Let's just do TSC. What I meant. Error files. Okay, so we tried running it inside the. What's that command? Oh, it's TSC dash init. So it's TSC dash init. Yeah, so the file is back. It should have like a bunch of things. Because like it was generated for us, but we don't need that. We just need to have this. So that's the end of today's video. I should be seeing you when I'm doing projects now. This will be next week, so I'm gonna go dark for now. And then on Saturday, we're going to upload a video starting a project. I might have to like go revise everything. Yeah, revise, write simple codes and test out why some stuff are working, why some stuff are not working before we start a project. And then we're gonna start. Bada bing, bada boom. Hope you enjoyed the video. It's just me learning, bro. See you on the next one.